In this video, we'll talk about assembly drawings and how they are put together. So for example, in this case, we have a pipe connector assembly and we have to create a special kind of layout for it on the drawing because it consists of multiple parts which are placed in a part list with the details of each part specified there. So I have here the name of the assembly, and here I have the numbering system for the assembly. If for example I have a manufacturing company where I produce pipe connectors, or I have to manage the design of them, this will be my first part connector number 1. And after that I will have my part drawings, which will be PC01 and then 001 for the first one, 002 for the next one, and so on. And this is done because we need to have some kind of way to manage all the documentation and to reference it. Now I'll start by creating the first half of the parts list here, and then the second half will be down here. So I'll just have to offset this by 10, and this is because the first actual the first row is the title row, and then after that we have to offset by a smaller amount, so offset by 7 for example, and we'll do this for 3 rows like that. I also want to extend this line here. Now I'll have to set, so I set the part number here at 10 millimeters from the left. I offsetted that by 50. This is where I'll place my part name. So mtext H7J MC for middle center, and this is the part name. Click outside. Okay, maybe I'll just leave that to name, so it's like that. Now the next field, I have to offset this by 45. Will be the place where we enter in our drawing number. So mtext, then H, I'll set the height of the text to 2 because I have more to write in here. Justification to middle center, and click here. So this is the drawing number or standard. Okay. The next one is an offset of 10 as well. This is the required number of parts for each, so the quantity for each individual part. I'll put my M text here and say J for justification, MC. The height I'll set it to 3 because I'll just write in the quantity like this, QTY for quantity. Okay. I'll continue this with the material field. So another offset by 30 here. And this is because each part may have its own material. So the material information in the title block here is not relevant at this point. We need to have a material specified for each part. And text starts here and has a height of 3, a justification of middle center, and there I can write in material. And this is where we also place the standard for which the material belongs to. And the final two fields will be the mass, so offset by 20, offset by 20, and some other remarks that have to be placed in. So the first one is the mass of the part. Height of 3, justification of middle center. So we have here the mass, and then we have some remarks here. So text here, height of 3, justification of middle center, and here, so we'll just shorthand this to REM, remarks. And usually these lines should be with a thin line here, so that we have some differentiation between the title of the table, the parts list, and the rest of the table, which are the parts themselves. And here I have to place my numbering from 1 to 3. So I'll place my first part here, second here, and third there. This is the way you place the parts from the bottom up. So after placing the parts here, the part numbers, I will copy the whole table, making sure to select everything that is relevant, and leaving behind by holding shift and selecting things that I don't need. And I'll have to move this right here. Now all I have to do is update these numbers, and I'm almost done. I clean this up a bit so it is like tidy, and it's now ready for me to place the part information here. But first I would like to start by drawing the assembly itself, and then I will fill in the information for each of the parts listed in the parts list. To start drawing my assembly, I first have to have all of my component parts already drawn on separate sheets of paper, so I can draw them here and actually bring them into the assembly drawing. So this is my uh, part collection here that I need to place in my assembly drawing. Each of these are drawings of the individual parts with their own information laid out, and now I have to place them in the assembly drawing here. I have this first we have a connector body here, then we have a connecting nut, okay, connector nut, and this is like a sleeve, so we placed in the connector sleeve, and here we have the spacer. We have a spacer here, and here we have an O-ring, so like a connector gasket, and here we have a pipe, and we have the relevant information. So for example, for the pipe, we can see it's part of the pipe connector assembly number 1, and it's part number 6 in this case. And we have an A4 here, but in the case of the connector body, the A4 was not enough, so that is why I brought in an A3. So let's change that to A3. Make sure all information is updated for the part that is being presented in the drawing. Generally, when you build an assembly, you have to start from the inside out, and this is what I did. I created an axis line so I can position everything on the same axis, and I brought in the pipe here, and I will slowly continue to add in the parts until I finish the assembly drawing. When something like this happens, when I have to place in two parts that have overlapping edges, I have to think about which part is visible and which one is not, and then rectify the drawing so that it shows only the visible edges in the assembly drawing context. When bringing the parts together, you have to also make sure that the hatch pattern is different amongst them so that we can differentiate between two neighboring parts. So in this case, this spacer and this pipe have the same kind of hatch pattern, so I need to change one of them. So I'll change the angle of the spacer to be something different, or the scale. I can also change the scale, so let me change the scale. And now we most certainly have a difference between the two hatch patterns. So we have 4 of the parts already placed. We have the pipe, we have the sleeve, we have the spacer, and we have the O-ring here, the gasket, and we have 2 types of parts that we can add now, the nut and the connector body. And this is also a symmetrical arrangement, so what we have here will also be on the other side. So I brought this over by disabling the dimensions layer. It's easier. And now I have to create a helping line here. because I need to place the part here in this intersection. So let's move that. From here onto this point. And now I can see I have a lot of lines that need to be cleaned up. So I'll have to do that so they don't intersect with everything. So after I decide that everything is in a logical manner here, as per the intersections between the parts, I can move on to placing the body, the connector body here. Just a moment. So this shouldn't be here. Okay. Go to the connector body here. And I'll copy this. And I'll place it. So I want to place this so it overlaps with the thread there, but also I want it to be placed up till the point where it touches the gasket. So I'll place it here for the moment, and I'll create a helping line that starts from this intersection until this intersection here, and now I can move it exactly to this line. So give the move command again, select, make sure you select everything. Now grab it by its midpoint here, because it doesn't have an axis, and place it where we drew the helping line in the intersection with the axis right there. And now we have some more lines that we have to take care of, so we can distinguish between the two parts, or rather the several parts here. We have to make sure that what overlaps we get rid of. Also, we want to establish to make sure that the assembly rules are followed. So where we have threaded assemblies, we have to edit the thick lines, so only the thread of the outside thread is visible. This is what we have to edit every line so that it follows that rule. We also have to clean up the hatch pattern a bit. So even though they overlap, we have to keep the hatch pattern of the external thread. So the external threaded part keeps its hatch pattern, and where it overlaps, the other part will have to lose its hatch pattern over the section where they intersect each other. In order to deal with this, you first have to explode this. So explode this so that it becomes individual lines, and then trim them out. You can either do this or redo the hatch, Now that we have this all sorted, we can mirror the parts on the other side. So we'll select everything here, making sure to deselect whatever is not like required to be selected. Line and the thread here as well. We don't need these to get mirrored, only the parts here. And or we can like do the assembly part again here as well, so you can either mirror this here or place them each one by one like we did before. So we want to snap to the middle and to the middle here. And enter. I'll have to edit this hatch pattern a bit to be like the scale. I'd like the scale to be a little bit closer together. So I'll place a value here of 5. It's too close. Let's choose 10. Okay, so that is, it's different than the other one, so we can make sense of the different parts that come in together to form the assembly drawing. And now we can also trim the excess axis line. We can let only like extend this with, and make sure we have the O snap turned on like ortho, and extend that by 3. And also here extend that by 3. So I gave this a dimension, but remember that this is the scale of 2 to 1, so this is not actually 100 but 200. And now we have to also build a side view here so that we can complete our assembly drawing. So we'll create some lines to help us like draw the projection here, and then for each like individual edge here we have to draw another circle. So there are quite a few circles to draw. We can use the X-line command to help ourselves see where those circles are positioned. So now we can draw another one here. So the center is the same, but it's the different position of the edge. So in this case we have another one here with another X line. Try to make sure the X lines are straight so we get the perfect correspondence. Then I need an X line here from here and another one from here, and those are all the X lines I need. So 2 more circles here, and this is the center. To here and to here. So let's see if I didn't miss anything. So this one, okay, this one, So because this one is the center, so the axis line, and now we can remove them after we finish drawing the circles. And I want to remind you that this is a hexagonal part, so we have to create the hexagon here. So give the circle command, start from this intersection, go to the center, and the same for here. To the center, we can remove this X line, tapping the delete key. Now we give the line command and start from here. Now we can remove these two circles, and this should be our axis line, but it should only like extend 3 millimeters on each side, and it should be placed on the axis layer. So I'll change it to the axis layer. Also, I need a horizontal layer, like a horizontal axis. So from this quadrant to the other quadrant, and then just extend it by 3 and extend it by 3, and now the two should be both on the axis layer, and all of the others without the two need to be on the thin layer, the thick layer, thick lines layer. Now I'll also give the dimension DIM DIA for this. And remember, this is the double this value, but we are at a 2:1 scale, so that is why it's showing like that. I also placed the section label and the section trace here, and we can also dimension the inside of this pipe here. So DIMLIN, click here and here, and we can actually place it outside. Remember, this is a diameter, so we have to place in the %% to get the symbol. And this is not actually drawn like a 2, it's more like a 4, but since we did the options for the styling of the dimensions, then it shows at a proper scale. And this is more like a functional dimension that you have in order to see like how the assembly will function in like a relationship to other things that may work around it. And it doesn't need to be like dimensioned all over, just a more like the surfaces that might come into contact with an outer assembly that will like assemble with this one. because most of the dimensions are already given in the dimensions of each part's detailed drawing. So now we can point to different parts here and say which one is part 1 and part 2 by using the mtext command and giving it like an initial starting point here and an h value of 7. So we have a large letter, and we place the 1, which is the first part, and now we create a line that goes from the near the letter, and we don't want it to snap to anything, just to reach the part that we want it to point to. And then we have to place like a disk here that will denote that this 1 refers to this part. So in order to do that, we'll use the donut command. And basically the donut command will help us do that. So specify the inside diameter of the donut. We want it to be 0. Then specify the outside diameter. We want it to be 1. And then we have to kind of specify where it goes, like that. So we can move that. And snap to the end of that. And similarly to this, we have to do the other parts as well. So maybe I won't delete these for the moment. So when I'm moving these around, I need to make sure I have them on a horizontal line. Then I'll delete the line. And so after finishing with placing of the labels here and filling in the corresponding names and properties in the parts list here, and also filling in the title block with the appropriate information, we can say that we have our assembly drawing done. So here you need to correlate the name of the part with its proper drawing number and the quantity present in the assembly drawing. So if I go here to the connector nut, I can see that the drawing is PC01-002 and it has two units here in the drawing. So the component is right here, and indeed it has the name connector nut, and the drawing is PC01-002. And if it was made of a certain material, that should be placed here in the material section. And also if we had a known mass per unit, we would have placed it here. Now in this case we don't have any standardized parts, these are all custom, but in some cases you may have standardized parts, and instead of pointing to the drawing, you'll point to the standard. So the reference here will be the standards number and details.